So take a moment now to copy the warm-up problems into your notebook and pause the video so that you can try them, and then play the video to see me going over them. So let me go over the warm-up here. We have this equation, which is a linear equation, y equals x, and I'm supposed to translate that right 6 and down 2. Well, we remember that we subtract 6 for right, and we subtract 2 for down, and that simplifies to y equals x minus 8. That is the translation of right 6 down 2 for y equals x. The number 2, this one's an absolute value graph, so we're going to still translate, but remember this time we'll have absolute value around the x. So I'm going to go ahead and write that, and I'm putting the x there. Remember that left 2 would be plus 2, and up 5 would be plus 5. That's the equation for the absolute value graph. I'm going to put the graph down here. So I'm just making myself a coordinate plane. I'm plotting the point, which is left 2 and up 5, which is going to be at -2, 5, right there. And the value in the front of the absolute value is just a 1, so I'm rising 1 and running 1 from that point, rising 1 and running 1 from that point. And I'm drawing in my absolute value graph from there, and just labeling the vertex at -2, 5. So there's our graph. Number 3, we're supposed to keep that same equation but include a vertical compression. Well, remember, vertical compression is when the absolute value of the number we're about to put in front is less than 1. So something like 1/8 in the front of the absolute value of x plus 2 plus 5 would work. Any fraction that's going to be less than 1 would be a vertical compression. Okay. Next, that was the warm-up. So then we got into the notes for today. Be sure to date your notes the 30th. And we're going to go ahead and graph this. So we notice this first part here, we can figure out the translations, the shifts. We can figure that out based on what we learned yesterday. So -3 we know is going to be a right 3 shift. And there's no number on the end, so it's not going to shift up or down at all. So if I go to 0, 0, where the vertex normally is, and I shift 3 to the right, there's my vertex, and that's going to be at 3, 0. Okay, and we're not shifting up or down at all. But next, we know we look to the number in the front there, and all the ones we did yesterday, they were just +1. So from that point, we just rose 1 and ran 1 on both sides, left and right. But here we have a -1. So -1 is going to cause this graph to change orientation. All right, so it currently, the normal absolute value of x graph has a positive orientation, meaning it opens up. Because of this negative sign, our graph is going to open down, and we call that a negative orientation when it opens down. By the way, a negative orientation is another example of a transformation. I gave you that term yesterday. Translation, remember, were the shifts, left, right, up, and down. Transformation, I told you vertical stretch and vertical compression are examples of transformations. Another example of a transformation is when the graph changes to a negative orientation. So looking at this number in the front, there's no vertical stretch or vertical compression because the value is just 1. But because of the negative, it is going to be a change in orientation. So it does still have a transformation. It's just that the transformation is not a vertical stretch or vertical compression. So no vertical stretch or compression, but it does have a negative orientation, meaning that it's going to open down. Okay, so we just said a minute ago that what we would normally do if it had a positive orientation is just up 1 over 1, up 1 to the left 1. But because it's a -1, I know I'm going down 1 and to the right 1 and down 1 from the vertex and to the left 1. And now I have 3 points, which means I can graph my absolute value from there. Okay, so there's the graph of y equals negative the absolute value of x minus 3. Okay, here's another one. So go ahead and put that equation into your notebook and draw yourself a coordinate plane. Now, you don't need to put all these directions down in your notes, but what we are going to state each one of these things it asks for. So it asks for the shifts first. So looking at the equation, we see x minus 2. We know that means right 2. We see minus 4 in the end, which we know means down 4. So I'm going to first go ahead and plot the vertex. I'm looking at 0, 0, and from there I'm going right 2 and down 4. So that takes me right here. I'm going to go ahead and label that. I can see that that's the point 2, negative 4. Okay. So that's another thing it asks for, the vertex. So I'm going to list that. Vertex is at 2, negative 4. Next, it asks for whether the graph has been stretched or compressed and the factor that it's been stretched or compressed by. Well, I'm seeing negative 3. So remember, we take the absolute value of that, which is just 3. And 3, we're going to compare it to 1. It's bigger than 1. And when the absolute value of A is bigger than 1, remember that's a vertical stretch. Okay, so picture being stretched. Remember, that means the absolute value graph is going to appear skinnier. So when we look at the graph, we should see it look skinnier than the normal absolute value graph. Okay, and then it also asks for the stretch factor. All that really means is the number that we're multiplying the absolute value by. So vertical stretch by a factor of, you could say either 3 or negative 3. Technically, the negative part doesn't make it have a vertical stretch. It's the 3 that makes the vertical stretch. So I'm going to say a stretch factor of 3. You could also argue, though, negative 3, and that would be fine. Okay, so that's our stretch factor. And then it says the orientation of the graph. Well, we know the negative does affect the orientation. It causes it to have a negative orientation. Okay, so I've listed everything it asks for except for the domain and the range, but I'm going to graph it first. It's easier to get the domain and range if you're looking at the graph. So let's go to our vertex, and we're going to use this number. So remember, negative 3, we're thinking of that like a slope, negative 3 over 1, which means from our vertex, we're going to go down 3 and to the right 1, and down 3 and to the left 1. And now we have our 3 points, which we can use to graph our absolute value. We already labeled the vertex, and our graph looks good. Now, looking at that graph, I can kind of check myself to see if it looks right. Well, it is opening down, which looks right because of the negative, and it does appear to be skinnier than the normal absolute value graph that we graphed yesterday, which should be right, because if I pull on the ends and stretch vertically up and down, I would get a skinnier absolute value graph. Okay, so that looks good. Lastly, we're ready to state the domain and the range. So I'm going to look at this graph to determine those. Domain. Remember, we're looking left to right. Well, I see arrows pointing in both directions. So arrows mean it's pointing towards negative infinity and positive infinity. That's the domain. And I'm going to put that in interval notation as well. And the range, I'm looking low to high on the graph. So I'm seeing it's pointing down, which means negative infinity. And I'm looking high and I see negative 4. But I'm noticing that this point at negative 4, it's a solid point, so it equals. So I know I need the equals. That's the range. In interval notation, it would look like that. That's our range. Okay. So I think we have everything that we were asked to find. So let's take a look at your assignment. Tonight's homework is pages 20 through 22 in the Unit 1 packet. On page 20, you'll see that all it asks for is the graph. So be sure to graph and label the vertex. But on pages 21 and 22, it asks for all of the items in the previous slide, all of the items that were in that example there. So the shifts, the vertex, the stretch or compression, and the factor, positive or negative orientation, and then the graph with the vertex labeled and the domain in the range. So be sure on pages 21 through 22 that you do all of those, not just the graph. Page 20, though, is just the graph with the vertex label. Okay, good luck with those.